January 15, 1944, Nibelungenwerk Tank Factory, St. Valentin, Austria. The production manager stared at numbers that contradicted everything he understood about war. His factory had just completed its best month ever, producing more Panzer IV tanks than at any point since opening in 1941. 3 months ago, Allied bombers had struck this facility, killing workers and damaging assembly halls. Production should have collapsed. Instead, it had increased. Across Adolf Hitler's Reich, the same impossible pattern was repeating at factory after factory. Germany was building more tanks in 1944 than it had built in 1942, even while hundreds of Allied bombers turned German cities to ash. The manager could not know that these impressive statistics represented a catastrophe masquerading as success. The tanks rolling off his assembly line would sit immobilized at railheads, waiting for fuel that would never arrive. They would be crewed by men with inadequate training, maintained by mechanics who didn't exist, and abandoned on battlefields, not because they were destroyed, but because they had run out of gasoline. The production reports looked like victory. They were actually documenting defeat in real time. The numbers themselves seemed impossible. In September 1939, when Germany invaded Poland, tank production averaged fewer than 100 units monthly. By 1941, before sustained Allied bombing began, Germany was producing several thousand tanks and assault guns annually. Production increased substantially in 1942 and again in 1943. But 1944, while Allied bomber fleets struck German industrial targets with unprecedented ferocity, became the year of peak production. The Panther tank averaged 148 units monthly in 1943. In 1944, despite intensifying bombing, Panther production increased to 315 monthly, peaking at 380 in July. To understand how Germany achieved this paradox required looking back exactly 2 years, to February 8, 1942. That morning, Fritz Todt, Reich Minister of Armaments and War Production, died when his aircraft exploded shortly after takeoff from Hitler's headquarters at Rastenburg in East Prussia. The crash occurred under circumstances that some historians have questioned, though no definitive evidence of sabotage has ever emerged. Within hours of Todt's death, Adolf Hitler appointed Albert Speer as his replacement. Speer was 37 years old. He had designed monumental buildings for the Nazi Party, including the massive structures at Nuremberg and grandiose plans for rebuilding Berlin as the capital of a 1,000-year Reich. But he had never managed a factory. He had never supervised industrial production. He had never dealt with steel quotas, machine tool shortages, or the complex supply chains required for weapons manufacturing. He knew nothing about armaments production. Hitler chose him anyway, based entirely on personal trust and their long association rather than any relevant competence or experience. The Germany Speer, inherited in February 1942, was shockingly unmobilized for total war. While Britain and the Soviet Union had converted their entire economies to military production, Germany maintained substantial civilian manufacturing. Automobile factories continued producing cars for private citizens in 1942, a full 2 years after Britain and America had converted every vehicle plant to weapons production. Luxury goods production persisted. Clothing factories made civilian apparel. The German economy in early 1942 operated on principles closer to peacetime commerce than total war mobilization. Tank production remained rooted in traditional German craftsman methods rather than modern mass production techniques. Vehicles were built one at a time by skilled teams working at individual stations, like custom furniture rather than industrial products. Each tank received individualized attention, with craftsmen making adjustments and modifications based on their judgment. This produced high-quality vehicles, but at glacial pace and enormous cost. Production speed depended on individual skill rather than systematic process. The Wehrmacht's procurement requirements changed constantly, forcing factories to retool production lines repeatedly. A factory might produce one variant of the Panzer IV for 3 months, then receive orders to switch to a different model with modified armor or different armament, requiring weeks of retooling before production could resume. Every change disrupted output and wasted time and resources. Multiple competing agencies controlled different aspects of weapons production, creating intentional dysfunction. The Wehrmacht had its procurement office. The SS ran completely separate production facilities. Hermann Göring's Luftwaffe controlled aircraft manufacturing and some anti-aircraft weapons. The Kriegsmarine maintained independent shipyards and weapons plants. These organizations competed viciously for resources, duplicated efforts, and sometimes actively sabotaged each other's programs to secure greater budgets and influence with Hitler. It was bureaucratic chaos that wasted resources Germany could not afford to lose. Speer's initial achievement was rationalization, bringing order to chaos through centralized control and standardization. He reduced the number of different anti-tank weapon types from 12 competing designs down to one standardized model. The bewildering array of vehicle types contracted from 55 45 different models to just 15. When Speer gained control over aircraft production in 1944, he cut airplane models from 42 types down to just 5, allowing factories to specialize and achieve economies of scale that had been impossible under the previous system. This standardization allowed individual factories to focus on specific products rather than constantly retooling for new variants. Workers developed deep expertise on particular assembly tasks through repetition. Supply chains simplified dramatically when factories needed components for 15 vehicle types instead of 55. The efficiency gains were real, measurable, and significant. Production did increase under Speer's reorganization, but recent historical scholarship reveals that Speer's so-called Armaments Miracle was largely statistical illusion built on manipulation and fortunate timing. The massive factory complexes that came online and began producing tanks in 1943 and 1944 had begun construction in 1940 and 1941, years before Speer's appointment. These enormous industrial projects required 2 to 3 years from groundbreaking to full operational capacity. Speer took office in February 1942, precisely as these facilities his predecessor had planned were beginning to produce their first tanks. He claimed credit for production increases that resulted from decisions made before he held any authority over armaments. More revealing was how Speer manipulated baseline statistics to exaggerate his achievements. He measured all production growth from January and February 1942, which were among the worst production months in years, due to harsh winter conditions that disrupted transportation and coal shortages that affected power supplies. By deliberately choosing this unusually low starting point as his baseline, even modest subsequent improvements appeared miraculous. If production in January 1942 stood at 100 units and rose to 200 by December, Speer could claim a 100% increase. But if December 1941 had already produced 180 units, the real increase was minimal. It was statistical manipulation designed to create the appearance of miraculous achievement where much more modest improvement actually existed. Still, production did genuinely increase through 1943 and into 1944. The method Germany employed to achieve this was brutal simplification that systematically sacrificed combat effectiveness for manufacturing speed. In February 1944, German factories began producing the Panzer IV AOSFJ, a deliberately degraded version of earlier Panzer IV models. Engineers systematically stripped away every component deemed non-essential to basic functioning. The electric power traverse system that allowed crews to rapidly rotate the turret to engage threats disappeared entirely. Crews now had to manually crank the turret using a handwheel, an exhausting process when rotating 40 tons of steel and armor. In combat, this meant German tank crews took precious additional seconds to engage targets that American and Soviet tanks with power traverse could target almost instantly. One of the vehicle's 2 headlights was removed to save copper wiring. Vision ports that allowed the turret crew to scan for threats vanished, drastically limiting situational awareness. The auxiliary engine that powered systems when the main engine was off was deleted. Rubber return rollers were replaced with cheaper all-steel versions that wore out faster and created more stress on the suspension. The quality of armor plate itself declined as high-grade steel alloys became increasingly scarce and were replaced with whatever steel was available. The Panzer IV rolling off assembly lines in late 1944 was significantly cheaper and faster to build than the sophisticated 1942 model. It was also demonstrably inferior in virtually every measurable way that mattered in actual combat. It could not traverse its gun as quickly. Its crew could not see threats as effectively. It broke down more frequently. It was, in essence, a degraded imitation of an earlier, better vehicle, but it could be manufactured in greater numbers, and by 1944, Hitler's regime valued quantity over quality because they had no other realistic choices remaining. The Panther tank, Germany's most capable medium tank design, and their answer to the Soviet T-34, suffered similar degradation through forced simplification. The original Panther featured a sophisticated final drive with precisely engineered gearing that distributed the vehicle's enormous power efficiently and reliably. But manufacturing these precision gears required specialized machine tools that Germany no longer possessed in sufficient numbers due to bombing and resource constraints. Engineers redesigned the final drive using much simpler spur gears that could be manufactured with basic equipment available at any industrial facility. The simplified final drive failed more frequently under the Panther's substantial weight and power output, leaving expensive tanks immobilized far from any enemy contact. From November 1944 forward, sleeve bearings replaced ball bearings throughout the Panther's drivetrain due to severe shortages of the high-quality steel alloys needed for proper ball bearing production. Sleeve bearings wore out significantly faster than ball bearings and required more frequent maintenance that crews in the field often could not perform due to lack of spare parts and trained mechanics. The accumulating effect of dozens of such compromises was a 1944 Panther that looked superficially similar to its 1943 predecessor, but functioned considerably worse under sustained combat conditions. Every change traded long-term reliability and combat effectiveness for immediate manufacturing speed. German engineers made these decisions not because they believed the modifications improved their tanks, but because the alternative was producing no tanks at all. The industrial base supporting tank production was crumbling under Allied bombing, and simplification bought time by working around shortages and constraints rather than solving the fundamental problems. Behind this production surge, beginning in 1943 and reaching its peak in 1944, stood a system of mass slavery that represented one of the darkest aspects of Nazi Germany's war economy. By 1944, approximately 7.5 million foreign workers labored in German war industries, constituting roughly 33% of the total industrial workforce. These were not volunteers seeking employment. They were prisoners of war, concentration camp inmates, and civilians forcibly deported from occupied territories across Europe and transported to Germany in cattle cars. At Nibelungenwerk, the workforce composition told the story of exploitation. Austrian and German workers formed only part of the total labor force. French prisoners of war worked alongside forced laborers, systematically deported from Poland, the Soviet Union, Italy, Greece, and Yugoslavia. Each group faced different levels of brutal treatment, but all were there against their will. In August 1944, the SS established a subcamp of the Mauthausen concentration camp system directly adjacent to the Nibelungenwerk factory, specifically to provide slave labor for tank production. By October 1944, approximately 1,490 concentration camp prisoners were working at the facility under conditions that amounted to systematic murder through labor. These prisoners received starvation rations barely sufficient to sustain life while performing physically demanding work, assembling tank chassis, installing heavy engines, and performing grueling manufacturing tasks for 12-hour shifts. They were malnourished, exhausted, and beaten by guards if they slowed down or made mistakes. Medical care was essentially non-existent. Minor injuries became infected and killed workers who would have survived with basic treatment. Austrian records and survivor testimony document at least 150 deaths among subcamp prisoners by March 1945, though the actual toll was almost certainly higher, as many deaths went unrecorded or were deliberately hidden. The French prisoners of war, though technically protected by Geneva Convention provisions, experienced conditions only marginally better than concentration camp inmates. After the Allied invasion of Normandy in June 1944, German authorities granted some French POWs holiday passes to visit their families in occupied France. A significant number never returned to Germany, choosing to risk escape and possibly execution over continuing their captivity. German management at Nibelungenwerk simply replaced them with additional concentration camp prisoners who had no possibility of escape, no rights whatsoever, and no hope of survival beyond their usefulness as labor. The most extreme and systematic exploitation existed in Germany's vast underground factory program, a massive construction effort that consumed enormous resources and tens of thousands of lives while producing relatively little useful military output. After the devastating Royal Air Force bombing raid on the Peenemünde V-2 rocket development facility in August 1943, Adolf Hitler personally ordered that critical war production be moved into underground facilities theoretically beyond the reach of Allied bombs. The Mittelwerk complex, carved into Kohnstein Mountain near Nordhausen in central Germany, became the largest and most infamous of these underground manufacturing centers. Beginning in late August 1943, thousands of prisoners transported from Buchenwald and other concentration camps were forced to excavate massive tunnels using hand tools, explosives, and whatever limited mechanical equipment could be procured. They worked around the clock in rotating shifts with grossly inadequate food rations, no fresh air circulation, and brutal discipline enforced by SS guards and prisoner capos who were often more vicious than the guards themselves. Prisoners slept in the tunnels themselves during the initial excavation phase, never seeing daylight or breathing fresh air for weeks at a time. The air quality underground was poisonous, thick with rock dust from drilling, chemical fumes from explosives, and human waste from the thousands of workers who had no sanitation facilities. An American technical intelligence team that investigated Mittelwerk after its capture in April 1945 heard testimony from survivors that approximately 250 workers died daily during the worst periods of tunnel construction. These figures come from survivor accounts rather than documented records and remain subject to historical debate, but what is absolutely certain is the conditions were deliberately murderous, designed to extract maximum labor output before workers died and were replaced with fresh prisoners. The Richard complex, excavated into mountainsides near Litomyjice in Czechoslovakia, employed approximately 3,000 workers to create tunnels intended for tank engine production. 5,000 prisoners died there before Germany's surrender, killed by the same lethal combination of malnutrition, disease, brutal working conditions, and deliberate murder that characterized all these underground facilities. Project Riese in Lower Silesia represented one of the most ambitious underground construction efforts, employing more than 13,000 concentration camp prisoners, most of them transported directly from Auschwitz. The facilities were never completed before Germany's surrender, meaning thousands of prisoners died for construction projects that produced absolutely nothing of military value. These underground factories suffered from crippling disadvantages that made them far less productive than conventional surface facilities they were meant to replace. Components and raw materials had to be transported between widely dispersed tunnel complexes located in different mountains, creating nightmarish logistical challenges. Quality control collapsed completely as starving, exhausted workers made critical mistakes or deliberately sabotaged production when they could do so without immediate detection. Survivors who lived long enough to give testimony after liberation described systematic sabotage efforts, with workers secretly loosening bolts on assemblies, deliberately damaging electrical wiring, and introducing subtle defects that would cause equipment to fail catastrophically after leaving the factory. The entire underground factory program consumed vast resources that could have been used for actual weapon production or supporting fighting units. Concrete, steel, excavation equipment, skilled construction workers, transportation capacity, and military supervision all diverted away from useful purposes. The program reflected the Nazi regime's fundamental dysfunction in its final years, pursuing grandiose ideological projects based on fantasy rather than practical military necessity. While German factories were achieving their record tank production numbers in June and July 1944, the foundation supporting mobile armored warfare was actively disintegrating. Germany possessed almost no domestic oil reserves within its pre-war borders. The entire Reich depended on just two sources for all petroleum products. First, synthetic fuel produced from coal at enormous chemical complexes scattered across Germany and occupied territories, representing decades of investment in advanced chemistry. Second, natural petroleum imported from Romania's Ploiești oil fields, which supplied between 30 and 40% of Germany's total petroleum needs. Both sources had critical vulnerabilities that Allied strategic planners finally began exploiting systematically in mid-1944. For years, the Allied combined bomber offensive had focused primarily on German cities in area bombing campaigns, aircraft factories, and ball-bearing production facilities with decidedly mixed results. But in May 1944, acting on intelligence analysis and strategic bombing surveys, the targeting focus shifted decisively to Germany's petroleum production infrastructure. The results proved catastrophic for the German war machine. On May 12, 1944, 935 Allied aircraft struck synthetic fuel facilities across Germany in carefully coordinated attacks, hitting multiple plants simultaneously. Before these systematic attacks began, Germany's network of synthetic fuel plants produced an average of 92,000 barrels of petroleum products daily from approximately 25 major facilities and numerous smaller installations. These sophisticated chemical plants represented decades of German engineering expertise and enormous capital investment. They were complex installations with specialized equipment that could not be quickly rebuilt or replaced once destroyed. The May 12th attacks damaged multiple critical facilities simultaneously. Allied bombers returned repeatedly over subsequent weeks and months, striking plants attempting to resume production before repairs could be completed. The sustained bombing campaign prevented any sustained recovery. By September 1944, just 4 months after the attacks began, German synthetic fuel production had collapsed catastrophically to approximately 5,000 barrels per day, representing a reduction of more than 92%. The industrial infrastructure that had sustained Germany's mechanized military forces throughout the war simply ceased to exist as a functional system. The second decisive blow to Germany's petroleum supply fell in August 1944, when Soviet forces captured Romania following that nation's sudden switch to the Allied side. Germany lost access to Romania's Ploiești oil fields virtually overnight, eliminating its last remaining source of natural petroleum. The mathematics became brutal and inescapable. More than 92% of Germany's aviation gasoline had come from synthetic fuel plants that Allied strategic bombing was systematically destroying faster than they could be rebuilt. Without aviation fuel, the Luftwaffe could not operate. Without vehicle fuel for tanks and trucks, armored and mechanized forces became expensive, immobile fortifications. The effects were immediate and devastating. The Luftwaffe operated on 10% of minimum required fuel by autumn 1944. Aircraft sat on airfields, fully armed and functional, unable to fly. Pilot training collapsed when fuel became too precious for instruction. German pilots who did train received 110 hours compared to 350 for American and British pilots. They entered combat with one-third their opponent's experience. Inexperienced pilots died quickly. The few veterans who survived became exhausted and died too. Desperate measures followed. Ground crews towed aircraft using horses, cows, and oxen instead of tractors. Breweries converted alcohol production to fuel, yielding tiny amounts of low-grade gasoline. By February 1945, aviation fuel production equaled half of 1% of early 1944 levels. The Luftwaffe ceased to exist, not because its planes were destroyed, but because they couldn't fly. Tank forces faced the same crisis. Panthers consumed fuel at half a mile per gallon. Tigers achieved 1/4 mile per gallon. Training became impossible without fuel. Germany built ersatz training vehicles powered by compressed gas or wood-burning systems. These could move but couldn't replicate combat. Crews learned theory but lacked experience with actual vehicles. Trained mechanics became as scarce as fuel. A Tiger company needed specialists almost as numerous as mechanics for an entire Panzer IV battalion. Tigers broke down frequently and required expert maintenance. Units received Tigers without adequate support personnel. The Speer Panzerabteilung 501 arrived on the Eastern Front in early 1944 with 45 Tigers. Only 8 were operational. The rest sat immobilized with mechanical failures that inadequate training had caused or failed to prevent. In December 1944, Germany launched its last major offensive in the Ardennes. The plan assembled significant armor, including new Panthers and King Tigers, fresh from factories. But the entire strategy assumed German forces would capture American fuel depots. Germany could not supply adequate fuel from its own resources. An army planning major operations around stealing enemy gasoline was an army facing collapse. On December 17th, Kampfgruppe Piper from the 1st SS Panzer Division reached the Stavelot fuel depot containing millions of gallons. American engineers had prepared demolitions. As Germans approached, they set the depot ablaze. Flames consumed fuel that might have sustained the offensive. Historians debate whether SS atrocities influenced the demolition decision, but the result was clear. Germany's last offensive lost its fuel source before truly beginning. German forces bypassed the burning depot and advanced. Within days, the offensive stalled. Across the Ardennes, German tanks sat abandoned on roadsides and in forests, immobilized not by gunfire, but by empty tanks. Crews walked away from functional vehicles because no fuel existed. Intact German armor sat useless while American forces maneuvered freely. July 1944 had marked Germany's peak tank production, but Allied bombing had shattered the petroleum industry. Transportation networks collapsed. Supply chains connecting factories to fighting units failed. Tanks rolled off assembly lines only to sit at marshalling yards. When they reached units, they often sat unused for lack of fuel. The Nibelungenwerk, where the production manager had reviewed those January statistics, manufactured 2,845 Panzer IVs during 1944, more than half that facility's entire war production. Yet by March 1945, only 117 Panthers remained on the Western Front, with just 49 operational. The manager reviewing production figures in January 1944 could not have known he was witnessing the beginning of the end. The numbers validated years of effort. They suggested continued resistance remained possible. But within 6 months, fuel to power those tanks would be gone, destroyed by bombing. Romanian oil would be lost to Soviet advances. Trained crews would be dead or captured. Mechanics would not exist. Spare parts would sit in warehouses disconnected from tanks that needed them. Industrial capacity means nothing without logistics, fuel, trained personnel, and maintenance. American tanks received fuel from industries producing millions of barrels daily. They had properly trained crews and functioning logistics delivering supplies across oceans. German tanks fought as isolated pieces of a failed system. Germany built tanks it could not fuel, operated by crews it could not train, maintained by mechanics it did not have, supplied with parts it could not deliver. The numbers looked impressive on reports. They meant nothing on battlefields where Panther sat abandoned for lack of gasoline. The factories won. Production statistics proved impressive. The war was already lost, and no number of tanks could change that when those tanks could not move, could not be maintained, and were operated by men who barely knew how to drive them. Germany's 1944 tank production demonstrated that industrial output divorced from reality produces only expensive scrap metal.